This is lesson 6.4, absolute value inequalities. Our goal today is to be able to solve absolute value inequalities. So we're first going to take a look at the two cases that come up, when x is less than and when x is greater than. So if the absolute value of x is less than 5, what that means to us is that x is less than 5 as one option, and x is greater than negative 5. Notice, when I change the sign, I also flipped the inequality symbol. And this is an and statement because it's less than, and the graph of this would be 0, you would have 5, negative 5, it would be open and open. Less than 5 but greater than negative 5 would be in between there. Therefore, when absolute value is less than or equal to, it's connected by and. The second case we have is when you're solving x is greater than 5. So, if we look at that, what that means is x is greater than 5 or x is less than negative 5. Notice again, when I plugged in the negative, I flipped the inequality symbol. So, you have 0, you have 5, you have negative 5, open and to the right, open and to the left. So the Euler inequality is doing exactly what we want it, going apart from each other. Therefore, when the absolute value is greater than or equal to, the solution to the compound inequality will be connected with or. So, less than is and greater is or, which we'll see down here in a second. All right? So the steps involved in solving a compound inequality is, first you got to get the absolute value bars alone. Then you decide if it's an and or an or. If it's less than, it's and. If it's greater, it's or. Then you make the bars away and write your two inequality. The first inequality, you keep the inequality sign and the right side of the number the same. The second inequality, you flip the inequality sign and make the right side of the number negative. Then you solve both and you graph. So, let's look at an example of what that actually looks like in action here. So in number 1, we have the absolute value by itself. So that we can go right into our two cases. So my first case is going to be just drop the absolute value symbols, and this is going to be x minus 4 is less than 3, because it's absolute value less than its and. The second case is x minus 4 is greater than negative 3. Notice when I plugged in the negative 3, I flipped the inequality symbol. So I'm just going to solve each case. Real simple. Add 4 to both sides. X is less than 7, and add 4 to both sides. X is greater than 1. So that's your inequality. If you go to graph this, you would have 0, you would have 1, and you would have 7. X is less than 7 and greater than 1, both open and connected. If you want to write your solution together, you can. X is between 1 and 7. Now, if you look at our second case here, what's different is that we have to get the absolute value by itself before we can approach the problem and set up our cases. So what we're going to do here is first I'm going to add 3 to the other side. Get rid of this 3. Again, not setting up my cases yet. Now I have 3, and then the absolute value of 2x plus 1 is greater than or equal to 9. I still have to get rid of this 3, so I'm going to divide that out. So the absolute value of 2x plus 1 is greater than or equal to 3. Because the absolute value is greater, it's or. So 2x plus 1 is greater than or equal to 3, or 2x plus 1 less than or equal to negative 3. You solve each case. This one you're going to subtract 1. 2x is greater than or equal to 2, x is greater than or equal to 1, or this one you're going to subtract 1, 2x is less than or equal to negative 4, divide out the 2, x is less than or equal to negative 2. So we go to our graph, we have 0, we have 1, negative 2, greater than or equal to 1 is closed and to the right, greater than or equal to negative 2 is closed and to the left, and that is the answer. So our solution is x is greater than or equal to 1, or x is less than or equal to negative 2. So anytime you have these absolute value inequalities, you have to get the absolute value by itself. Once you get the absolute value by itself, you can decide if it's and or. Less than is and, greater is or, and then you just set up your two cases. The first case is exactly what you have, the absolute value, and the number stays exactly the same. The second case, you keep what's in the absolute value, but you do two things. You flip the inequality symbol, and you give the negative to the number. And that happens in both kind of cases.